Okay, so our learning goal today states I can solve problems involving exponential growth and decay. Not only are you going to solve them, but sometimes you have to set them up. Okay? So let's read this top part up here where this is going to be where we're definitely going to be doing some highlighting. In exponential growth and decay formulas, they each have their own formula. I want you to highlight that y is the final amount. So when you see the y in the formula, in the equation, you know that is representing the final amount. As we've already talked about, A being like the starting amount is going to be the original amount. How much did it start with? And then there's going to be an R in the formula, and that is the rate of growth or decay. And note what it says, as a decimal. So they're probably going to give it to you as a percentage, and you're going to have to change it to its decimal name. And then, last but not least, there's going to be a T in there, and that's going to represent time. Whatever time is measured. So the next thing I want you to highlight for me is the actual formula for exponential growth. Exponential growth. When we believe that something's going to increase, it should grow, this is the formula we should use. Y equals A times, notice the B has been replaced. It's not A times B, it's what's taking the place of the B? 1 plus R. What else has been replaced?
The X.
The X value, what has the X been replaced with?
Time.
Or T, yeah. Okay, Mrs. Allen. So we're still working with exponential functions, and this is our exponential function model. Remember, y equals a times b to the x power. Our b, our base, is going to be changed to either 1 plus r if it's exponential growth, or it's going to be changed to 1 minus r. There's our other formula that we need to highlight, exponential decay. The b will be changed to 1 minus r. And so, again, the 1 plus r or the 1 minus r, that's what's replacing the b. And the t for time is replacing the x, which is very typical that in an exponential function, the x value is representing time. Okay? Cover those markers up. Put them down. Okay. I want you to read through the population of a city is increasing problem. I want you to read through that on your own right now, because I'm going to ask you some questions about it. While I come back up those highlighters, because they are going to be a problem otherwise. Go ahead, start reading. I'm not going to read it to you. Population of a city is increasing. You guys are really not fast readers on speed readers. Okay, turn your papers over. Please tell me something about this problem. One thing with a hand. Turn your papers over. No looking at the left side. You're supposed to be reading. And you read when something stays with you.
Population was rising by 4%.
Okay, the population was rising at a rate of 4%. Okay, Devontae.
They wanted 4% of 236,000 people.
So they wanted to know what 4% was of 236,000 people. I'm wondering if the starting population was
It was.
236,000 people. And it was, doing what Cody said, it was increasing at a rate of 4%. Did they ask for what 4% of 236,000 people was?
No, they asked what it would be, okay, so this was, instead of the 200, they said what was the population of 2009?
So, Cody, you don't get to speak anymore because you've had, the floor. Now it's somebody else's turn. Tell me something else. No?
They want us to find the population of 2003 to how it increased to 2009.
Okay. So they wanted us to tell something about how much the population increased from 2003 to 2009. Okay. Anything else you can remember about it? Okay, so did you look at the formula and what they substituted into it? Let's go take a look at it. What did they put in for A?
2006.
Oh, Cody, remember what I said? You're going to rest your vocal cords for a bit here. What did they put in for A? Abby? 236,000 because that was the original amount. Okay? Noah? Okay, you knew what was coming next. What did they put in for R?
4% as a decimal.
Okay, and what is 4% as a decimal? 0.04. And that's going to be really important that we, first of all, change our percentages to decimals correctly, or we're going to get some maybe wild answers. Because that 0.04 is going to get added to 1, correct? Why does it get added to 1? What do you think is the reason for that? What would be the reason? If it's increasing at a rate of 4%, and 4% of the decimal is 0.04, why in the world would they add that to 1? Your vocal cords can't stand it any longer? Okay, go ahead, Cody.
Is it because it's rising in population over a certain amount of time? So you're gonna have to add to it, or it's gonna decrease when you use the exponent for time 24 plus 1 is gonna go down, but you have one that's gonna start to go up to big.
So the 1 is what's going to make it go up, you think?
It's gonna help it go up.
Going to help it go up?
Because if we take 1.04 times 236,000, the decimal's still going to go over. However, we place it in our zeros.
So we're going to try it a little bit here. We're going to see, maybe we can figure out why that 1 is there. I think you're kind of on the right track here. What did they put in for T? Julie, what did they put in for T? 9. Did you see a 9 in the problem anywhere?
Nope.
But I know.
Oh, Cody!
Oh, come on!
I don't think I got it.
Thank you, Noah, for raising your hand. Way to go. Where was there a 9 in this problem? No, there's no 9 in this problem.
I know.
Abby? 2009. So 2009. So they grabbed it from the 9 of the 2009.
I know why we had one.
Is that where it came from, Julia?
It's the amount of time from 2000 to 2009.
Oh, it's the time span from 2000 to 2009. Because what did they tell us about the year 2000, Calvin? It was a good year. You were born in that year. You were, weren't you? That's a good year. Okay, so is that why? Where they, what was the reason for why is 2000 such a big deal? Other than it's the year you were born. That's a good thing.
There were 236,000 people.
In that year.
Yeah.
So that was at the start, wasn't it? So the year 2000 is like what value for T? What value would T be when in the year 2000 in this problem?
0.
Time would be 0. It's at the when it's the year 2000, it's 0. When it's the year 2009, t is 9, isn't it? So what would the t value be in the year, this year right now? 17, but it's 2017. Okay. Noah, you think you've come upon knowing why we add 1, huh?
Yeah.
Okay, why do we add 1?
Because in the original equation, they already had one there. In the exponential growth, they add 1 to r.
Yeah, they do, but why do they?
Because it's exponential growth.
Okay.
In an exponential decay, they subtract 1.
Let's try something with our calculators. 236,000 times 0.04. So in other words, don't add the 1, just take it times 0.04. It's growing at 4%. Come on, folks. So just take it times 0.04. What do you get? 9,440. Okay, 9,000. You guys agree? 9,440. So what does that 9,440 actually tell us? Is that the population at that time?
No. Well, that is if it's decreasing.
That is if it's decreasing, okay. So 9,440. Well then, will you tell me what happens when you take 236,000 times 1.04? You know, let's have that 1 added in there. What's 236,000 times 9 or times 1.04? No, what do you get?
245,400.
245,000 what?
440.
440. So tell me if I wrote this right.
Yep.
Okay? Huh. So this is the 1 plus 0.04. This is just the 0.04. So what's this tell us?
It's larger. Going up.
It's going up.
Exponential growth.
I wonder how much it went up.
It went up. I'd say.
Tell me what that is. Tell me what 245,440 subtract 9,440 is. Oh, 236,000 being all we started with. So if we have to figure out the population at any given time, do we have to include what it was at that time?
Yes.
So when we found this, we only found what? The 9,440. If we put that down as our answer, we said this is what the population is now, it's 9,440, would we be right?
No.
No.
That's way off.
It's off, it's way off. What is it really telling us? Cody?
It's growing by, I think that 9,440 is how much it's growing.
That's how many people it increased by. It increased by 9,440 people in that, 1 year's time. Okay, so now we have to make sure we include what was the population before, because that doesn't even make sense that if it started at 236,000 and it's growing, it would end up at 9,440.
That's why we add the 1.
So we have to add the 1. We have to have what the population was. 100% written as a decimal is what? 100% written as a decimal is 1. So we have to have the 100% of the population that's there right now, and then we have to add how much the percentage it's going to grow by. So we can't leave out those people that are already there that we started with, right? If it's going to keep growing. Okay, well now notice in the other one, the population of the city is decreasing at a rate of 6% each year. What did they do in that one that's different?
It's
They-
tracked.
If it says decay, so it's going down.
It's going down, so you have to subtract. So what ended up being 1 minus r in this problem?
1 minus 0.606.
Okay, and so what is 1 minus 0.06? 0.94, okay? And notice that's right here, isn't it? What was the starting population of this city, Tori? 35,000. What year is the starting year in this problem, Faith? What's the starting year in our decaying population? What's the starting year? 2000 again? Okay. And why is T12, Devante?
Because that's year they want you to find.
That's the year that they want you to find, and how do you get 12? Why did they put 2012 in there?
Because
It's 2012 minus 2000.
Yeah, you have to take 2012 minus the 2000, the starting year, and altogether really 12 years that's going to have passed. Okay, now I want you to notice something, and I want you to put boxes, arrows, something. When they ask you to give a model or write the exponential function for the situation, notice what stays in there, the y and the t. Just like we do whenever we write equations for something. We always have the y and the x. They're left as they get so that we can substitute into our equation whatever we want to put in it. These are the models for each of these situations. In the first situation, the population started at 236,000. That's not going to change. It's increasing at a rate of 4% per year, so that 1.04 is not going to change. But now, you can figure out what the population will be given what year you want to find it out for. So when somebody says, okay, tell me what the population is going to be in 2020, you could do it. Will you find what the population of that increasing cities, what's its population going to be in the year 2020?
increasing one?
In the increasing one. Go ahead, Calvin. Have after it. Find the population of the city that is increasing in the year 2020. Use the model.
It'll be,
Just relax, Cody. Okay. What's the t-value for this one, Aurora? 20. What's the population for this city after 20 years? Cody?
172,105, roughly,
Roughly?
because there's the decimal point.
Rounded to the nearest person?
Yep.
Okay, you guys agree with it? So, what can we say that in 20 years, don't give me something that we can say about the population of the city did it?
20 years grows exponentially.
It did grow exponentially. Yeah, we do that. So, what else? Started at 236,000, so 517,000. If I wanted you to make some, sensible, intelligent statement about the population of the city, what could you say happened after 20 years?
The population grew, so the city grew to make it so that the whole population fit the city.
Devante?
The population grew 281,105 people.
Oh, it grew, so he figured out exactly how many people it grew. Did it more than double? Yeah, because 281,000 is more than 236,000, isn't it? So did it more than double? Did it triple? No, it didn't quite triple it, but it did double in more than doubled in 20 years. So we should be able to make some conclusions also. Okay, let's go practice some of these on our own now. Annual sales at a company are $372,000 and increasing at a rate of 5% per year. Okay, I want you to notice something. And this is, I'm going to be really picky about this in your homework, so tune in. I'm going to be really picky about this in your homework. There's two things to do for these problems. Number one, write an exponential growth function to model the situation. Your exponential growth function has to have a y in it and a t in it. Has to. The only thing you're going to replace is the a and the r. Okay? Then, number two, second part of the problem. Then find the value of the function after the given amount of time. Okay? So, I want want you right now to do all the things that we would, first of all, we're going to decide it's increasing. So which model should we use?
The exponential growth model.
So how's that one go?
Y equals A times 1 plus R times to the exponent of T.
Okay, so for the model, the only thing we're gonna replace is the A and the R. So A equals, what's our A value? Okay, write that down, 372,000. You don't have to worry about the labels in our work here.
Times.
No, we're not doing it, we're just deciding what are the things we're gonna replace. What's the R value? As a decimal?
0.05.
0.05, okay. Now we are ready to write our model. Y equals 372,000
Times 1 plus 0.05.
1 plus 0.05
The T power.
to the T power. We will clean that up. Because you know what? Can't we do this? 1 plus the 0.05. Y equals 372,000 1.05 to the T power. Here's number 1. The model that will help us get the sales of this company in any given year. Okay, this one, do they actually talk about the years? Do they say what year it is?
No, but it tells you after 8 years that you want.
So what's our starting year for this one? What's our
0.
usually I just kind of
2001.
well, we don't even have to make one up. We don't have to worry about figuring out, oh, when T is 0, it's 0. So what's our T value going to be in number 2?
8.
T equals 8 after 8 years. This is where we need to worry about the 8. Now we're going to put into our function y equals 372,000 1.05 raised to the 8th power. My 8 should be outside those parentheses. I just kind of ran out of room there. Now we can use our calculators. We're going to figure out what is y equals. Rounded to the nearest dollar and cents because this is money. So to the nearest penny, to the nearest hundred. And when you're done getting your own answer, let your calculator show you its wisdom and rounding to the nearest penny or nearest cent. See if you agree with me. In other words, this is what I believe the second answer is. But if I'm wrong, let me know, because I could be. Agree with me?
I do not agree.
You do not agree with me. Okay, what do you want it to be, Cody?
5,000.
5,000?
Or 500, 520, or 589.77 dollars.
You guys agree with them?
Look at what you got.
Oh, yes, no.
I think I'm gonna stick with my answer.
I'm going to also. I misplaced
Okay.
the 7. I put a 4 instead of a 7. My bad.
Okay.
Yep, I got your answer.
Okay. Should we expect our answer to be something like that? Is it reasonable?
Yes.
Why?
Because it's in the ballpark.
Why is it in the ballpark?
It's in dollars.
Big hairy deal is in dollars and cents.
It's bigger.
Calculator says
It's
so.
bigger.
Than 372,000, and it says increasing.
Oh, that's a really good reason. It's bigger than 372,000 and it says it's increasing, so it better be
It
bigger.
says it's supposed to increase in the next page.
Okay. I want you to read through the next one and I want you to set step one. Step one. Read through it. Decide first of all which exponential formula you should use. Identify the parts that you need. Go over. Okay, you should be done with step one for me by now, right? Okay, which model should we use? 1 minus R or 1 plus R? 1 minus because it's decreasing, okay? What's our A value? 1200, 1200. What's our R value? 0.02. Substitute into our model. 1200. 1 minus 0.02. That's to the T power. Cleaned up, that is 1,200 times 0.98 to the T power. There's our first answer. Okay. Now we're ready to move on to step number 2, which says, you're going to figure out how many people this will be, participants this will be after how many years? 5 years, so T equals 5. Okay, we'll figure out how many participants would be in this chat room after 5 years. And you must show your substitution step before you let your calculator do its thing. This is people, so we'll round to the nearest whole number. Whole person. Are you ready for Cody to challenge me again? Okay. What'd you get, Abby? Okay, but couldn't we round up? We'll just do the nearest whole. Okay. If it wasn't a point like 7 or something like that, yeah. So we'll just go to the nearest whole. I know we can't have part of this, and I get that. And then what label will we put on this? People, participants, one or the other, yep. Okay. Does our answer make sense?
Yes.
Okay, why? Go ahead, Julia. And yeah, it's less than the starting amount and it's decreasing. So don't just be happy to have an answer and trust that your calculator was good to you. Take that time to say, does this answer seem reasonable? Because if it was a decreasing situation and your answer is larger than the starting amount, there's a problem. And same thing if it's increasing and your answer is less than the starting amount, that's a problem. Make sure you make sense of that. Okay? Questions, anyone? Okay, then let's go to work on homework.